So, just to do a little example, if I had to integrate x squared plus 3dx, that is the same thing as the integral of x squared dx plus the integral of 3 dx. The integral of x squared is 1/3 x cubed, and the integral of 3 is 3x plus c. If I had to integrate 5 over x squared dx, there is no quotient rule. That's the integral of 5x to the minus 2 dx, which is 5 times. It's 1 over minus 2 plus 1 times x to the power of minus 2 plus 1 plus c. That'll give me minus 5x to the minus 1 over x plus c. So you'd want to be a little bit careful of that. And finally, if I had the integral of x plus 1 to be squared times x minus 1 dx, there is no quotient rule, so what would I have to do with all of that? I'd have to multiply it out. It becomes x cubed plus x squared minus x minus 1 dx. That's the same as the integral of x cubed dx and x squared dx minus x dx or minus 1 dx. X cubed, 1/4 x to the 4 plus x squared, 1/3 x cubed, minus x, 1/2 x squared, minus 1, minus x plus c. So there is no product rule. We're also aware of that. The integral of x squared minus 1 over x plus 1 dx is the integral of a quotient, and there is no quotient rule. So you must divide. How would you divide? Well, you do along the division. In this case, it factorizes. X squared minus 1 is like x minus 1 by x plus 1. It's the difference of two squares over x plus 1 dx. They cancel. It's like the integral of x minus 1 dx. The integral of x is 1/2 x squared minus x plus c. And we explained to you yesterday why there is the constant in integration. Finally, a special note on log x. If I have the integral of 1 over x dx, it is log of x. Because when I differentiate log x, what do I get? 1 over x. Yesterday I showed you how the integral of x to the minus 1 using this method here gave division by 0, which is undefined mathematically. Right? If I have the integral of 1 over x plus 2 dx, it is the log of x plus 2 plus c. If I have the integral of 1 over x minus 5 dx, it is the log of x minus 5 plus c. And if I have the integral of 1 over 3x minus 1 dx, it is the log of 3x minus 1 plus c. But see, I've gone from an x to a 3x. In differentiation, once I went from x to 3x, I called it, then became chain rule. That 3 causes 1/3 when you integrate. What would the 3 and the 3x cause in differentiation when you differentiate? 3 times, yes? Whereas when you integrate, it causes the fraction. If I have the integral of dx over 2x minus 5, that is 1/2 the log of 2x minus 5 plus c. 1 over causes the log, yes? And the 2 on the 2x causes the half. Now I'm going to explain where that fraction comes from a little bit better. If y was equal to the sine of x, Then dy dx, when I differentiate sine x, I get cos x. Any questions? If y was equal to sine 5x, what do I call that? A chain rule. Why a chain rule? It's a function of a function. You have 5x first, and then you have its sine. So to differentiate that, we would have said to you, u is 5x, and that means y is equal to the sine of u. Du dx is equal to differentiate 5x, 5. And dy du sine u becomes cos u. Then dy dx is equal to dy du by du dx. Dy du cosine u by 5, which is 5 times the cosine of u, 5x. We know now that if y was equal to sine 7x, that dy dx becomes 7 cos 7x. If y is equal to sine ax, we know that dy dx becomes a cos ax because we've done it so often. Yes? Now, if y was equal to sine 5x, I know that dy dx is equal to 5 cos 5x. Dy is equal to 5 cos 5x dx. Now, how do I go from dy back to y? Integral. So the integral of dy is equal to the integral of 5 cos 5x dx. Y is equal to, because the integral of dy is y, 5 times the integral of cos 5x dx, because the 5 can be taken out, which is equal to 5 times. The 5x causes what fraction? A fifth. And integrate cos x, sine. The 5 times the fifth, cancel, is 1 is sine 5x plus c. So therefore, if you integrate cos x dx, what do you get? Sine of x plus c. That's in your logs. Yes? And the rules are on page 26. But what if I integrate cos 2x dx? What do I get? A half sine 2x plus c. Integrate cos 2x and I get sine 2x. Where did the half come out of? Because it was a 2x. If I asked you to integrate cos 3x dx, cos 3x becomes sine 3x plus c. But what does the 3 and the x cause? A third. And if I ask you to integrate cos ax dx, what do you get? 1 over a times sine ax dx. Similarly, if I integrate sine ax dx, I get sine becomes minus cos. So I get minus 1 over a times cos ax plus c. So if I asked you to integrate sine 4x dx, I will get minus 1/4 cos 4x plus c. Do you understand that? So in differentiation, the 5 on the x causes what? 5 times. In integration, that 5 would cause what? A fifth. Because 5 times the fifth brings you back to where you were. Yes? Do you understand that? All right? So, if I asked you to integrate 3 cosine x dx, that 3 is a constant. It's like 3 times the integral of cos x dx, which is 3 times cos x sine of x plus c. If I asked you to integrate 5 sine x plus 4 cosine x dx, you know that's the same thing as 5 times the integral of sine x dx plus 4 times the integral of cos x dx, which is 5 times sine x minus cosine x plus 4 times cos x sine x plus c. But if I asked you to integrate 3 sine 2x plus 4 cos 3x dx, that's the same times as 3 times the integral of sine 2x dx plus 4 times the integral of cos 3x dx, which is 3 times. Now this 2 on the x causes what? A half. So it's minus a half cos 2x plus 4 times the 3x, 1/3 sine 3x plus c, which is minus 3 over 2 cos 2x and 4 over 3 sine 3x plus your constant. Do you understand that? So now, another little note. I know this is a lot of info, but I think a lot of it I have gone through yesterday. If I integrate e to the x dx, it gives me e to the x plus 2. When you differentiated e to the x, you got e to the x. If I integrate e to the 4x dx, I get integrate e to the 4x, I get e to the 4x plus c. What does this 4 cause? 1/4. Yes? Whereas in differentiation it would cause 4 times. If I integrated e to the 6x plus 2 dx, I will get e to the 6x plus 2 plus c, and the 6 on the x would cause 1/6. And if I integrate e to the ax, I'll get 1 over a times e to the ax plus c. Any questions there? If I asked you to integrate twice e to the t dt, it is twice the integral of e to the t dt, which is twice. Integrate e to the t, e to the t plus c. But if I asked you to integrate twice e to the 5t dt, you'd say it's twice the integral of e to the 5t dt, which is twice. Now integrate e to the 5t, 1/5 e to the 5t plus c, which is 2/5 e to the 5t plus c. So in all of that, I've been